So now that we completed iteration 5, we'll move on to iteration number 6. But before I do that, I did not commit, and also I was intrigued by this comment from Xcode on the NSArray. If you click on that, it says casting from the URL between square brackets to unrelated type always fails. And then I looked that up, and this square brackets is a shorthand version to arrays in Swift 3, and it is connected or bridged to the NSArray, but it is being pushed in the new version of Swift as the area to go. So if you can look at it on the Apple developer website. If you go to the Apple developer website, developer.apple.com, and search for the Swift programming or the basics of the Swift programming language, you get to that link, the language guide. And on the language guide, you see the collection type. And I had that link on module 2, in module 2 checklist. And you can read about arrays here, and read about the shorthand syntax of an array using the square brackets. And it gives you some information here on how you can initialize and how you use the array. So if I want to change this from an NSArray to the regular array, I will start by changing the type that I created here in notes. And instead of writing NSArray, I can use the shorthand type and saying that notes is an array. And I can provide the type of the array by including the URL type here. So this definition says that notes is an array, and the content, each element of that array is a URL or the URL type. And the exclamation mark is the same, saying that I'm not initializing here. And once I do that, if you notice, URLs as a function returns this type. If you let me write it again. If you look at the app bundle and look at the URLs, that is what it returns, the square bracket with the URL in between, which is very similar to notes. So now the type between what URL returns and what notes is matches. So this extension here is not needed. I don't need to change the type, so I can delete that. The square brackets is a reference to a collection, so it says it's inside it. What's inside it are elements, so you can put inside that square bracket the index, and it will return to you the element at that particular index. So I don't need to use the object function in the notes, because now notes is not an NSArray, and I don't need to convert to the type, so I can delete all of that, and just next to notes put the square brackets, and inside the square bracket put the index that I want to retrieve, which is random index. And that will be it. So it's much shorter, and there's no type conversions as we had with the NSArray. So as we make that change, we can go ahead and commit and push this change to the repository. So completed iteration 5, and used array shorthand instead of NSArray. And this array, the type is called array without the NS, and it has the shorthand of the square brackets. So you can use array instead of the shorthand as well. And we'll say push and commit the two and push. So now we're ready to go and move to iteration 6, evaluating the user answer. So we'll say 6.1 problem formulation, or 6 here, evaluate user answer. There's a lot of work that need to be done here in this iteration, so this will be quite large. In this iteration, the scope is play random notes inside a game, which means 3 turns, and collect user answer and evaluate the answer. The testing, we will, number one, we need to test that we're playing 3 turns. We need to test that correct answers are recognized correctly, and we need to test that incorrect answers are recognized correctly. Game ends after 3 turns, and testing scenario 2, correct answer is identified correctly, and testing scenario 3, incorrect answer is identified correctly. Then the solution formulation is our biggest piece. In the model, the model is the same as before, no changes in the model. We need to add, actually, in the model, we need to add the number of turns. So the number of turns, which is an integer, because this will be important. And when you use the number of turns, we're going to have a counter. So we have the number of turns, which is the maximum, which in our case here is 3. But we also need a counter. So we call it the turn counter. A counter for the number of turns. A counter for the number of turns. And this also can be an integer. And then in the view, we'll need to follow the mockup. So we'll need to add the buttons to collect user input. In the controller, we have several things we need to do. Number one, we need to implement the turns. So this will require us to introduce the play game function, and in the play game we'll test if the turns has reached the maximum. If not, play a random sound. If yes, end the game. And then we also need to, so this will be the first thing that we need to do. The second thing we need to do is to evaluate the user response and play another, and then redirect to play game. So that's the main 2 things we need to implement in the controller. So in the solution implementation, step number 1 we're gonna have is to build that game turns. And I had this diagram in the music learning PDF document. In the music learning PDF document in module 4. And what this show you are the different steps for the game. So in the beginning, we are waiting for the game to start. So this is pressing the game. So this is that state here. You're waiting for the user to press the start game. And then once the user presses start game, the game will start. When you play the game multiple times at the start of the game, and you will see this evolve, we will be resetting the game, and then we'll go to play a game. And playing the game means managing the number of turns and iterating for each turn to play a sound, wait for the user to select an answer, check the answer, and then play another one. Wait for an answer, check the answer, then play another one, and so on until the number of turns are completed, will reach its maximum, and if that's the case, you end the game. Every time you play a turn, there's also a reset turn. So there's a reset turn and then reset again. So to better manage this inside the controller, we'll create a function to play. We have a function to play a sound. We'll make one to play a game, which doesn't really show up here. But the play game will incorporate all of the management of the turn. And we will need a separate one to check the user answer. And we'll have also the end game and resetting the turns. So we will need to add play game function to manage the number of turns, and then we'll need to add buttons to the screen and connect the buttons to a check answer function, and in the check answer function evaluate and redirect, and finally test and commit. In order to evaluate the number of turns and evaluate the user answer, we're gonna need to learn how we can make our program evaluate, and I have something here for it. So in order to allow the program to evaluate, we'll basically meaning allowing the program to make a decision, we'll use a construct called if-else. This construct has this format: the keyword if, followed by parentheses and a condition, followed by a block, keyword else, and then another block. The idea of the block is you put all the instructions that you would like to be executed if the condition evaluates to true. So this is a logical expression or logical condition that evaluates to correct or incorrect, true or false, yes or no. If it is true, correct, or yes, the instructions inside this block that follows the if will be executed. If it is incorrect, false, or no, then it will be skipped, and instead the instructions inside the else will be executed. So the if statement is a very powerful construct, as it allows your program to make a decision on the fly and decide whether to go in that direction or in the else direction. A condition is any expression that evaluates to true or false. So for instance, 5 greater than 6, that's an expression, because when I ask you 5 greater than 6, you will tell me no, or incorrect, or false. So that then is an expression. There are several logical operators that you can use to construct an expression. There's a less than, greater than, greater or equal, less or equal, equal, or not equal. In addition, there is a compare function available in many library objects. So we'll see how we can implement that as well. So building the play game, we do not need to do anything on the storyboard. So back to our view controller.swift and add a new function called play game. So what should happen inside the play game? For now, since the play game is going to manage the iterations, we will need to evaluate if the iteration has reached the maximum or not. So to do that, we need to define an iteration counter. So we'll define that inside the class block, so we have access to it in multiple functions, and it is retained with us as well. So we could say variable turn counter, and we'll initialize that to 0. And if you initialize it, you don't need to provide a data type for it. And I also want to create a maximum number of turns. So I'll say maximum turns equal 3. The maximum turns, I don't know why it created an error in the beginning. There is no error here. The maximum turns is defined or created with the let keyword because I'm not going to change it. It's a constant. And I give it an initial value, which is how many turns I want to have. Whereas the turn counter will change throughout, like it's going to increment from 0 to 1 to 2 to 3. And this is why I defined it to var, which is a variable. So in the play game, what I need to do, I need to increment the turn counter. So every time you come to play a game, I'll increment the counter. So I'll say turn counter equal turn counter plus 1. So I started with 0. So the first time we play, that's turn number 1. The second time, that will be turn 2. The third time, that's turn 3. Then I will need to check. So I'll use the if statement and put the condition. So what is my condition? If the turn counter is 3. So if I say if turn counter equal 3, if that is true, meaning that I reached the end, but do I want to do the third turn? Yes, like if the turn is 3, then I'm still working. So I actually need to keep iterating, keep playing the game as long as the turn counter is less or equal 3. So if I say less equal 3, so as long as the turn counter is less or equal 3, so if it's 1, 2, or 3, if that is true, then we are playing the game. Then game still in game. But if that is not true, then if that is not true, then I need to end the game. You see? So this if statement will say anything related to actually playing the game, like playing the random note, should go inside that block that will be executed only if the turn counter is less or equal 3. And I shouldn't really write 3 because I defined a constant, so I'll use the constant name maximum turn. So if the turn counter is less or equal the maximum turn, then I need to play the random note. So I'll say play random note. If not, if it is not less or equal, meaning that it became 4, which is like one more, then you should not play anymore. You should end the game directly. So how would play game start? It will start from the start game. So now start game, I had play random note there. No, I should not put play random note here and put instead play game. So when the game starts, I'm going to start a new game and manage the iterations. And if I still have iterations, then play the random note. So let's go ahead and try that. And the difference between this try and the previous one, when I press the start game, I should hear the sound 3 times. 1, and actually there's no 3 times because I don't have yet the play game. In order to see it playing 3 times, I need to add the buttons and let the user check the answer first. So let me add one button so we can test that. So I'll add a button here. And I'll give the name on the button to be the same as the note name or the note file name. And I will connect that button with a function to check the answer. And I'm not going to check the answer now. I just want to get the function to activate the play game again. So from the button, connect to create another action. And that action, we're going to need a sender. And the sender will be the UI button so that we know which button the user selected. We're going to follow a mechanism in evaluating the user answer similar to what we did in the help screen by grabbing the text on the button and using it to know what the user selected. So we'll call this check answer. But for now, in the check answer, I'm just gonna call play game again, and you'll see that when the user click the button indicating that they have an answer, that another sound will be played, then another sound will be played, then a third sound will be played, then after that no sound will be played until you hit start game again. So let's see that. We'll wait for it to build. Yeah, it's taking longer than it should here. But you can move the video forward. So this is too long, so I'm gonna try to stop it and run it again. So if you click start game, so here is a sound, I answer, another one, I answer, a third one, I answer, no more. So keep answering as you wish. It goes back to play game, but the counter now is more than 3, so it's not gonna play any more sound unless you click on start game. And if you click on start game, it's not playing the sound as well, because one of the things we discussed before is this concept of resetting the game. One of the things I have to do at the beginning of every game is to reset that counter. So that's why when I press the start game, we're not hearing anything again. But for now, my objective was to show you the management of the number of turns. So now we have the management of the number of turns in place. I just need to add in the start game resetting the game. So I will call here, I'm going to create a function to reset the game first. And so we'll say function reset game. And the one thing I want to do is to reset the turn counter back to 0. And then in the beginning of a start game, I want to call reset game and then call play game. All right. So the next thing that we wanted to do is we wanted to evaluate the answer and know if the answer is correct or not. So we'll follow something very similar to this, but maybe before we do that, let's add the rest of the buttons for all the notes. So on the storyboard, copy the button and place it again. And I'm gonna call and then name them with the exact name as the file name. Very similar to what we did with the help screen. And we'll make this B and we'll make this C. Then we copy them and paste them. So this will be the C sharp, the D sharp, and the E. And then I'll make another line for the rest of them. Probably need to make them bigger and move them to the middle a little bit. and I think all of them will be connected to that check answer function. So when we check the answer, I need to get the actual note name and compare it with the the node that is being selected at random. So let's go back to the standard editor and go to the view controller to see how we can do that. So in the check answer, I need to compare two things. I need to compare the note that was selected here, and I only have the file URL that has the actual note. So I need to find a way to grab the note from the file URL. And if you look at your output screen, here is the file URL. This is the full file URL, which has the full path to the file. But at the end of it, there is the last path component, which is the actual file name, the note. This is the note, and this is the .mp3 attached to it. So if I can extract from this the c.mp3 and somehow get the note name from the button and attach the mp3 to it, I will have two things that I can compare. Because right now I have apples and oranges. I have a URL in the random note, and I have the file name in the sender text, in the button text. So I have to convert both of them to become in a format which I will use here, the format of the full file name, the a.mp3 or the b.mp3. And once I do that, I can then compare the node that was played with the button that the user selected and determine if the answer is correct or if the answer is not correct. So first I need to resolve an issue that the play node, the file URL has the scope inside, is created inside the play node function, and I need to check the answer inside the check answer function. So we have a scope issue. So we need to create a variable that can be accessed in both functions. So we need to create a variable in the class scope. So I'll create one that is a variable, and I'm going to call it current note. And the note here will be a string type. So I will define it to be a string type and will not initialize it. And then in the play note, random note, when we get the file URL, I want to assign the current node. So I can do that here at the end. Assign note name to the current node. So I say current node equal, and then I can say the file URL and see if it has something called last path component, which give you the last string in the path, which is the c.mp3, and the type is a string, as you can see. So this current node will now have the c.mp3 or whatever it is, the last component of the file URL. Similarly, I need to get the text from the button and attach the mp3 to it. We extracted the text in the help screen, so we can use the same thing that we did there. So we can say that let user selected node, we can start first with the button text equal sender the title label text, which gives us a string, and add the exclamation mark. So I have the button text, which will be the A or the B or the C. Then I need to attach the mp3 to it, and I can do that by adding or appending to the text. So I can say let user selected text, or I can use a string with format. So I can say button text and see if I can append. I can append here, which returns a new string made by appending a given string to it. So I can say append to that mp3. No. So here it is. So I have now the user selected text. So I can then compare the user selected text with the current node. So I can say if the user selected text equal current node, if these two are equal, then this means that we have a correct answer. Else, this means we have incorrect answer. So how do we know? How do we know? Let's just log for now. So I'll just log correct answer. We have a whole iteration to manage the feedback to the user, and incorrect answer. And when you add a string like that, you don't need the extensions to it. All right. So let's see. So then this means that if the answer is correct, we will see it here in the output. I deleted the output screen from here. And then run again. So we'll look and see, we'll cheat a little bit, see what random note is being played and select the correct answer, then another one and select incorrect answer. So we should see both text being printed, and we can compare and verify that the flow is working correctly. And then we'll need to do the cleanup. So we started the game. So we heard the A sharp. So let me do a correct answer. So let's see if we got a correct answer or not. We got incorrect answer. So this is C. So let me do a C. And I got the C. And it also said incorrect answer. So the comparison using these two together is not working. So let me see what text is coming. I want to see if it is the equal operator or if there's something in the append. So we'll start and then make an answer. So I selected A, which will then take me to the debugging. So the current node is a variable here. So here is the current node, and it says a.mb3. The text of the button is A. So let's see when we append what it becomes. I forgot the dot. So it comes AMB3, and it should be, and of course, if you compare AMB3 to A.mb3, the answer is incorrect. So I forgot to put the dot here. So I put the dot and run again, and I think it will be correct. So I don't need the breakpoint. It should be correct now. So start. So we got a G sharp. So we test the G sharp. Here is a correct answer. And we got an F sharp. So let me do a D. We got incorrect answer. And then we got a C. So answer the C. We got correct answer. So the flow is working correctly. And now we didn't get anything at the end. So we need to identify the end game. So maybe I can add a function to end the game. And add it here. So I'll say function end the game, and for now let me just log end the game. We'll manage that, and then in the else statement we'll say end the game. So we have the entire flow in place, that we wait for the game to start. We start the game, we reset the game, we play a sound, and wait for the user to select an answer. The answer, we come back, we check, and keep doing that until the game is ending. And when the game ends, it tells us that it ended. So here is an incorrect answer, and we got another one, so we get a correct answer. Then we have a third one, and we get a correct answer, and then we don't get anything, but we should have end the game, and here it is end the game, indicating that we reached the end of the game. So So that's, I think, everything we needed to do here. Evaluate and redirect, test, and commit. So let me go back, commit, and we're ready to move to the next iteration and manage the build the game workflow from starting playing turns, managing the number of turns, and evaluating the user answer and ending the game at the end. What we need now is we need to work on the user feedback to provide appropriate feedback at each step of the process, and we'll do that. That's next iteration.